In this video, we're going to talk about tasks, and tasks aren't really like a Arduino specific programming type concept. It's just a general idea to kind of help guide us in designing our programs. And so a task is just kind of a chunk of work, and what we're going to do is try to divide things up into these various chunks of work to kind of give us the idea that we're doing multiple things concurrently or at the same time, right? And so our Arduino can only run like single lines of code at a time. But by breaking things up into tasks and trying to share the processor in some way, it can kind of give off the idea that we're doing multiple things at once. So like for example, we could build a weather station using an Arduino and a sensor called a DHT11, which will read, temperature and humidity values, right? So we could break up different tasks to say, hey, read the temperature and humidity every minute, read the wind speed from an anemometer, and then check a real-time clock to see if there's any errors in the timestamp, and then try to store that information in like a SD card or display it to a screen or something like that, right? So there's all these different tasks that are happening at different rates throughout the program's lifespan and things like that. But the Arduino itself is still only running one line of code at a time. It's pretty similar to how your phone or like your computer works, right? Like you're on your phone, you might be like in like a social media app, right? But you're still getting like text messages and emails and things in the background. There's multiple things happening at once, although typically there's just kind of like one line of code running at a time within there. And so we're going to kind of talk about how we can give it this illusion of concurrency or being able to do multiple things at once. And so the first thing we'll talk about is event task handling, right? And so what we mean by an event task is just it's triggered by an event. Some external stimuli is telling us to do something. And that's kind of like what we were just doing in that last example, right? Where we were toggling the LEDs on and off, right? There was some external stimuli, me pressing a button that was telling it to do something. And then we used conditional statements to check if something has occurred, right? So if I go here and pull up this, right? This is an example of me implementing a program with event tasks, right? This is an event. When I press the switch, that's happening. So we've kind of already done this a little bit, right? And we could almost think of these as independent events, right? There's an event that is triggering the red switch, there's an event that's triggering the green switch, an event that's triggering the blue switch. Those are kind of all different tasks, although they are fairly simple. We can extrapolate out these ideas for like more complicated programs and systems. But that is kind of the idea of like an event task in a nutshell. Like we're checking to see if some event has happened, which is sometimes referred to as polling, and then once it's happened, we're going to go do that, right? But particularly as we get more and more complicated types of events, polling can have some cons. Like you could envision like if I had a button that would play a song, while it was playing that song, it wouldn't be able to check if other events have occurred, so we could miss those. And so an alternative that we'll talk about to mitigate that issue is using interrupts, but we're going to talk about that later on. So this is just kind of another example, right? Like if a push button is pressed, perform some task. If it receives some serial input, that's the number 2, do this other task. There's all sorts of different events that could trigger a task, but this is typically what it looks like, is we have some conditional statements here and then the code associated with that task. And this is kind of driving home the point that we talked about a little bit earlier, right? So we had used else ifs when we just wanted one thing to happen. It's either this, this, or this. Here, where we want to use if statements, because sometimes multiple tasks can be ready or be triggered at the same time, right? So if a push button is pressed and the proximity detection is tripped at the same time, we want it to be able to do this task and then this task. We don't want it to not do this task because it did this other one. So using if statements is going to be really, really helpful. And that's why if we go to our example here, that's why when we're checking these switches here, we use an if statement, because otherwise it wouldn't necessarily, like if it found that the red switch was checked, it wouldn't check the green switch until it came all the way back around again. All right, so that's our first idea, and we kind of already did an example of that. Another type of task that we can have is like an interval task. So if we only want something to happen like periodically, it's not a great idea to use delay. That can hang up the processor, right? If I'm saying I only want something to happen every 5,000 or 5 seconds, I would say delay 5,000, meaning wait 5,000 milliseconds. But we couldn't do something that entire time, right? The program just waits at that one line of code until that delay is done, and then it will continue on. So we're going to look at how to use millis to mitigate that and implement interval tasks. And so what this means is, like, we could have like 3 different tasks here, and in this case we'll have like a red light task, a green light task, and a blue light task. And once the timers for those have elapsed, once some amount of time has passed since the last time we did it, we will perform that task. And so I'm going to show you how to set that up. There's some good information here about how to do it. So what we're going to essentially do is kind of define the intervals over which we want it to happen. And I'm going to kind of write these out in milliseconds. And then what we'll do is we'll record the last time that it happened. So these are going to be something called a global variable, which is a variable that's defined outside of setup and loop, so that it can keep its value and it's not erased every time loop runs over and over again. And so what we'll do is we'll define, okay, maybe we want the red interval to be 5,000, corresponding to like every 5 seconds something will happen. And so we'll say, if the time since we last did this task is now greater than this interval, let's make that happen. So this is kind of a quick snapshot of it. Let's go in and actually implement it here. All right. So I'm actually going to create a new sketch, but keep some of this stuff here since we're doing a lot of the same thing. So there we go. Slowly but surely it's coming up. All right, so I don't need any of this switch stuff, so I'm gonna get rid of that. And here's some more switch stuff. But I'm gonna keep these things here. And we're gonna do that first thing that it said. So I'm gonna use pound define. We've only used it for pin numbers up until now, but we can also use it for these intervals. So I'm gonna name these like, what it is describing _ interval. So this is like the red task, the interval, and then we'll make this be like 5,000. And what we're going to do is just make these lights blink at different intervals, basically, just to kind of showcase this idea, and then you can build on it to make more complex things from there. So that one will be 1,000. Keep holding down the shift there, and then this one will be, let's do it really short. Let's just do like 100. All right, so we can kind of see the difference of what's going on here. So these are our intervals, and these are macros. These are going to be constant values that we can't change, but we will refer to them. And then what we want here is we want to keep track of the last time that it happened. So what we're going to do is we're going to create a variable called like previous red, and then previous green, and then previous blue. And it's going to store an integer value, but I can't just describe this as an int. What I'm going to do is describe it as a long, which is a special type of integer that can store more information. And the reason why we're going to do that is we're going to use something called millis. So if I go here, and I can search through here, it's under the time section on the Arduino reference. We're going to use this millis function. And what it does is it says it returns the number of milliseconds that has passed since the Arduino began running the current program. And it tells me here that it returns it as a long, because as you can imagine, like, this number is going to get very large over time, and an integer value won't be able to store it. At a certain point, it won't be able to store large enough value. So a long is just a special type of integer that can store more information. So we're going to use a long. So if I go back here, it even says that it's an unsigned long. So we don't have to get into all of that, but we'll just define it as that. And I'm going to initialize it. If I initialize it to 0, we'll kind of see what happens here. So I'm going to just do the same process here for all of these. And these are global variables. And the reason why we're defining them here is so that if I define them inside of loop, every time they would get reset to 0. And what we want to do is store like the previous time that this event was triggered. So what we'll do is we'll write some expression like this. So millis gives us back the number of milliseconds since something has last happened. So I can say if millis minus the previous time that the red task executed, which is just starting at 0, meaning that the last time it was executed was at the start of the program, if the difference between these two values here is greater than my interval time, then we want to execute this task. Okay, so this is for our, we'll call this our red interval task, right? And let's see, we'll make our red interval task, what should it do? Yeah, it's just gonna toggle the state. So it'll say, if it was on, turn it off. If it was off, turn it on. So you could look up, how we did this in the last one where we checked its value and then toggled it. I could copy and paste that, or I could just write it again, right? So I can say if digital read on LEDR, if it's high, what we need to do is turn it low. So then I'll say digital write LEDR low, and then I can say else digital write LEDR high. Oh, and I forgot my semicolon there. So if this works correctly, every 5 seconds it should blink. So let's upload it. Let's go to our camera view. Oh, I'm gonna tile my windows better. All right, so it's on there. Let's see. Okay, it came on after 5 seconds, and then it should go off after 5 seconds. Could have done a slightly smaller amount of time, I guess. Oh, it's not going off. Why is it not going off? So we're saying if it's high, turn it low, else do that. Oh, I know why it's not going off. So it came on because millis minus that was greater than that. But that's still the case. Millis minus the previous value of R, because that's 0 and I never changed its value again, it's still greater than that. So what I need to do is, it's basically toggling this on and off really, really quick. So what I need to do is the last step here that I forgot to do, is I need to set this now equal to millis. We can imagine millis is giving us a timestamp. It's the number of milliseconds since the program began. And so now what we're doing is we're recording the previous time that this happened. So you could either start this if statement with it, or you could put it right here and end it with that. Either way would work. But now we should see, hopefully, it starts off, it waits 5 seconds, and then it turns on, and then it goes off. So let's check and make sure that happens. All right, there it's on, and then hopefully it should go back off. There we go. All right, so now it's toggling on and off. So we can follow the same process here for our other tasks, right? So we had a green one, so we'll do the green interval task. And let's copy and paste. So this one should be G. We'll use our G interval. And then for each of these, I'm going to make this LED G. And then we'll just do our blue as well. Let's just do it all. Let's go for broke and see if it works. So this is blue. This should be B. This should be B. And then what we'll see is, since they're changing at different intervals, it should mix the colors in interesting fashion. So it might be a little bit difficult to keep track of what exactly is happening, but we'll see. So red should be 5,000, blue should be 100, green should be 1,000. Oh, I did miss something. I missed, in my copying and pasting frenzy, I forgot to change this. So this should be green, this should be blue. Now let me upload it. Okay, so our blue's blinking really fast and our green was on, then our green's on. Okay, now it's yellow because the red came on at that time too. So yeah, that seems to be working. So that is kind of how this system works. The behavior that we saw first before I incorporated the green and the blue is that the red doesn't come on immediately. because what happens is it's comparing the current number of milliseconds to previous R, and previous R is 0. And so it's not going to trigger its first time until the 5-second mark. So after I've powered it on for 5 seconds. So if I want this to have happened already, what I should do is, and I'm realizing that's why I had this unsigned. Unsigned means you can't do negative values, so we're going to get rid of that. What I want to do is I'm going to start previous R. Instead of starting it at 0, I'm going to start it at -R interval, because that means that it'll happen right at 0. So it'll start right at the beginning there, as opposed to waiting for 5 seconds. And then the green won't wait for 1 second to begin, because we're setting the previous time that it happened as the negative interval, meaning it would start right at the beginning. So just a very small difference in the program there to make it start right at the beginning. So we'll see that it starts out with red, and that's why it's yellow there for a second, and it blinks between yellow and white, because it starts by turning on the red, green, and blue at the beginning, and then the blue blinks on and off every 100 milliseconds, and the green comes off there. So it just goes to red, and then red and purple, and then yellow and white, and so on. So that's how this program works, and that's kind of a very, it's a contrived use case of using intervals, but this is a very helpful notion when you're designing more complex programs. If you want things to happen periodically, this is a good way to design your program. So hopefully this example was helpful.